Hey everyone, and welcome. Today we're going to tackle one of the most fundamental skills in all of electronics, how to get a physical input into your project. We're going to connect a simple push button to an Arduino and turn a real-world press into a digital command. It seems so simple, right? You press a button on a game controller or your coffee maker, and stuff just happens. But have you ever stopped to think about how that physical push actually gets translated into a language a tiny computer like an Arduino can understand? Well, that's exactly what we're going to break down today. So let's meet the star of our show, the humble push button. At its heart, it's really just a simple switch. Think of it like a drawbridge. When you're not touching it, the bridge is up, there's a gap in the circuit. But when you press it, you close that gap, completing the circuit and letting that sweet, sweet electricity flow. It's a simple idea, but it's the foundation for everything. Okay, so first things first, let's get our hands dirty with the hardware. We need to actually build the physical circuit that connects all our parts to the Arduino board so they can talk to each other. And don't worry, this is way more straightforward than it might look. And here it is. This is our blueprint, our map for the whole operation. It shows the Arduino, our push button, our resistor, and all the wires connecting everything. This diagram is going to be our guide, and we'll just follow it step by step. Let's break this down. It's really just 3 simple connections. First, one side of the button connects to the 5-volt pin on the Arduino. That's its power source. Second, the other side connects to a digital pin, in our case, pin 2. This is the pin the Arduino is going to listen to. And finally, that same pin also connects through a resistor to ground. Now, this is super important. It's called a pull-down resistor, and it makes sure that when the button isn't being pressed, the pin reads a stable, quiet, off state. All right, our circuit is built, but right now, it's just a body without a brain. To make it actually do something, we need to upload some code to the Arduino. Let's take a look at the sketch that brings this whole thing to life. So here's the entire code, or sketch, as it's called in the Arduino world. Now, I know, looking at a block of code can sometimes feel a little intense, but trust me, we're going to walk through the key parts one by one, and you'll see how each line has a very specific job. The first crucial command you'll see is pin mode. This happens in the setup section, which, you guessed it, only runs one time when the Arduino first powers up. We set pin 2 as an input because we're expecting to receive a signal from the button, and we set the built-in LED pin as an output because we plan to send a signal to it to turn it on. Makes sense, right? So how does the Arduino listen? It uses this function, digital read. Inside our main loop, which runs over and over and over again, the Arduino is constantly checking pin 2. It's asking, is the voltage high or is it low? It then stores that answer, high or low, in our button state variable for later. And next up is the real decision maker, the if-else statement. This is just pure and simple logic. It tells the Arduino, hey, if that button state variable is high, I want you to do one thing. Else, if it's not, I want you to do something different. This is how our code can actually react to the real world. Okay. We've wired the hardware, we've gone through the software, now it's time for the magic. Let's put it all together and see exactly what happens step by step when you finally press that button. This is the aha moment. Okay, here we go. You reach out and you physically press that button down. Click. That little switch inside our circuit is now officially closed. The very instant you press it, that 5 volts of power can now flow all the way to pin 2. In our code, the digital read function, which was just hearing low, 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 suddenly sees this rush of voltage and reports back a high signal. So, because digital read returned high, our button state variable is now high. That means the question in our code, if button state equals high, is finally true. The condition has been met. And because that if statement is true, the Arduino executes the code inside it. It sends a high signal to the LED. And just like that, the little built-in LED on the board turns on. A physical action has been translated into a digital output. You've done it. So when you really boil it all down, what did we just do? Well, we took a physical switch and built a complete system. The circuit gave it power and a path to talk. The code, using pin mode and digital read, gave the Arduino ears to listen. And finally, that if-else logic gave it a brain to actually act on what it heard. That is a complete input, process, output cycle, and that's an incredibly powerful concept to master. You've now officially mastered a fundamental building block of physical computing. You can take an action in the real world and have your project respond to it. The possibilities from here are Well, they're endless. So the only question left is, what are you going to build next?